Hello everyone, my name is Nikhil Suktankar. I have a total experience of 20 years in IT infrastructure space with expertise in large account delivery and transformation. My topic today will be 5G and its impact on industries. 5G has been in hype for many years now, and in fact, it is up and running now in many countries. At present, 5G has begun to be used to develop technologies in various fields such as medical, automotive, entertainment, and many other aspects. So, before talking in detail about 5G, let's understand the G and the evolution of Gs. So it all started with 1G in 1980s. 1G focused on voice communication in the analog voice form. In this technology, we were unable to transmit any data, not even receiving and sending text messages or SMS. You could dial only within the country. 2G started in 1991. It focused on digital voice communication, which will make the sound clearer. We could send text or SMS and could connect to the internet, but with a very less speed of 0.5 Mbps. 3G began in the 1998s. This was the beginning of the true mobile broadband era. 3G was notable for its speed and data transmission with an emphasis on high-speed wireless connection. This allowed for a perfect multimedia application, and we could transmit both video and audio in a wireless system at high speed, around 42 Mbps. This also allowed for a wide variety of applications such as calling, video calling, playing games, etc. 4G started in 2008 with a peak data speed of 100 Mbps, which was 4G LTE. Today, we have speeds around 1000 Mbps with 4G LTE Advanced in some places. Obviously, this helped us to upgrade video quality and various games to full HD and also made live streaming more smooth. With 4G, there was also a possibility of ride-sharing apps like Uber, etc. So, 4G has brought society meaningful breakthroughs since its launch in 2010. Some of the examples: mobile gaming apps like Candy Crush, Pokemon Go, maps in terms of Apple Maps, Google Maps, etc. Mobile payments like PayPal, music streaming like Spotify, Amazon Music, etc. Ride sharing apps like Uber, video calling, we use Skype, Zoom video, etc. So, when 4G is already bringing such benefits, why do we need 5G? Let's try to decode. So 5G technology is a combination of software algorithms, firmware, and new hardware. Once users have a 5G capable device, they will benefit from many improvements, which includes lower latency, increased speeds, high density, added capacity, and energy efficiency. So let's go through each of these functions briefly. So on lower latency, 5G networks deliver 10 times lower latency than 4G. Specifically, 5G provides 5 millisecond over-the-air latency, which is a meaningful decrease as compared to 4G networks. 4G networks provided latency level around 50 to 100 milliseconds. This means 5G offers instantaneous, always on and always connected network. Commercial use cases for lower latency would be cloud-based gaming, streaming video on your phone, obviously with no buffering, apart from augmented reality and virtual reality. Business user cases for lower latency would be smart manufacturing and robotics. Lower latency allows workload from machinery, sensors, and devices to be put on network. Moving on to increased speed, 5G speeds have the potential to reach 10 gigabytes per second, which compared to 4G could be 100 times faster. However, 5G developments are not all created equal. 5G in the current state comes in three different layers: low, mid, and high band 5G, which have different characteristics. Low band, typically which is at 600 megahertz spectrum, offers only modest improvements with the speed of 100 megabytes per second. Deployments of low band 5G spectrum is for coverage purposes. This is why low band can provide nationwide services to more and more people. Mid band is somewhere around 2.5 gigahertz spectrum. On mid band, you could get peak speeds up to 600 to 700 megabytes per second. And however, in reality, the users may experience speeds up to 300 to 400 megabytes per second. In high band, which is 24 gigahertz and above, typically it will offer the fastest speed reaching 1 gigabyte per second to 2 gigabytes per second. Additionally, high band has a potential for further improvements up to 10 gigabytes per second. Use cases for increased speed, it could be video streaming, more high definition video streaming like 4K and 8K. Moving on to higher density. So high density means that 5G has the ability to support 10 times more connected devices per square kilometer of network as compared to 4G. On a 4G network, only 100K devices could simultaneously operate in 1 square kilometer. In comparison, on 5G network, 1 million devices can simultaneously operate in 1 square kilometer. So use cases because of high density. Now, because the scarcity of connections is eliminated, it allows more sensors, more devices, and other Internet of Things devices to be connected to the tower cell site. As a result of this increase in density, sensors can be cost-effective and can be used in many different industries. However, some of the use cases could be utility management, pipeline management, and traffic management. Moving on to the added capacity, 5G will increase network throughput, which is the amount of data that goes through a tower cell site by 100 times. Throughput increases drastically with 5G with the possibility of 10 terabytes per second per square kilometer. In comparison, 4G only has a throughput of 1 gigabyte per second per square kilometer of network currently. Some use cases for added capacity. So improved network throughput will make phones react faster. This will enable users to accomplish more in each sessions for their phone. This is also relevant for cloud-based application where more capacity allows more bits to travel from cloud to the phone or phone back to the cloud. And finally, on energy efficiency, so 5G, like many people believe that 5G requires more consumption of energy and resources. However, it actually requires less consumption of energy and resources. By optimizing the radio signals, 5G allows for 10% of the current energy consumption experienced in 4G network. This translates into an energy efficiency of 90%. Use cases obviously would be from the environmental standpoint. By achieving energy savings up to 90%, this could result in more longer battery life for phone users. Apart from whatever is mentioned in the slide, the additional noteworthy difference is security. 5G has an end-to-end security architecture. This includes stronger subscriber authentication, user privacy, and network security as compared to 4G. So now let's look at some technology terms in terms of 5G. So first, let's go to millimeter waves. So millimeter wave is also known as millimeter band and is the band of spectrum with wavelengths between 10 millimeters, that is 30 gigahertz, and 1 millimeter, that is 300 gigahertz. It is also known as extremely high frequency band by the International Telecommunication Union. Typical advantages for millimeter wave could be less use frequency spectrum, so that means more data, less noise, etc. Moving on to massive MIMO. So wave frequency and antenna are inversely proportional. Higher frequency works well with smaller antennas. So massive MIMO increases the number of transmitting antennas at the base station. So it further expands the total capacity per base station by enabling communication with multiple devices using the same resources, creating a virtually unified device experience. Small cells. So typically, when you have higher frequency waves, you have more collisions and lose the frequency loses energy. So millimeter wave covers shorter distances and are easily blocked by buildings or trees. Hence, small cell stations will have to be used between base and users. One cell can have many more users. So distance between the cell depends on the population. So for example, densely populous cities may have cells between 10 to 100 meters. Moving on, beamforming. So 4G signals are spread over a large area and typically lose energy. Beamforming will make the waves between the user and the base directional. So the high density leading to less interference and less energy consumption that will ultimately result in faster data rates. Moving on to NOMA, which is the non-orthogonal multiple access, and this is one of the promising radio access techniques in the next generation wireless communications. Between 1G to 3G, multiple access methods which were based on frequency, time, and code were used. However, NOMA will use power level of user devices to access base station. This multiple access method will allow different signal using the same channel simultaneously, which will definitely provide high sum rate than the orthogonal method. And finally, on the mobile edge computing, which is MEC, so typically it will use the existing cloud computing, but this clouds will be on the edge of the network. So that means closer to the user or local to the users. Typically, the latency sensitive applications could be on the edge of the network. So you could also do application splitting in terms of task split between the device and the cloud. So we have heard so much about 5G. So let's brace for the 5G generation. And this generation will impact wide variety of industry. This will include enhanced interaction between human to machine, and machine to machine. While 5G will impact wide range of industries, for my tech talk, I will be touching upon its impact on automotive industry, Industry 4.0, and healthcare. So before we speak about 5G and automobile, it is important to understand a few details about autonomous vehicles. As you know, autonomous vehicles have gained significant attention in recent years. However, the underlying technologies that support them, including 5G and digital infrastructure, needs to be understood. Autonomous vehicles are also known as self-driving cars, driverless cars, or robot cars. If we talk about the leaders, there are some innovative companies like Google, Tesla, Uber who are already working on autonomous vehicle and are leaders in this field. So now let's look at autonomous vehicle levels. Autonomous driving can be classified in 6 different levels, from traditional vehicle being level 0 to fully autonomous vehicle being level 5. Level 0 represents a vehicle where a human is in full control of the vehicle at all time. Today, level 0 vehicles have incorporated early warning systems or an intervention system. Moving on, level 1, which is the ADAS vehicle type, represents vehicle where steering, braking, and accelerations are augmented by driver assistance system. However, a human performs all the critical driving tasks. Example of level 1 features adaptive cruise control, emergency braking, and lane correction. Level 2, which is also a type of ADAS vehicle, represents vehicle where steering, braking, and accelerations are done by driver assistance system, but a human must monitor the system at all times and perform all remaining aspects of dynamic driving tasks. Example of level 2 features include adaptive cruise control, that is acceleration, deceleration, steering, and self-parking. Level 3, which could be also known as conditional autonomous vehicle, where autopilot takes stage. So autopilot performs the driving task under defined circumstances such as low speed traffic jams. Furthermore, a human driver does not have to monitor the system at all times. However, a human driver is required to respond if there is a request and to intervene and thus drive the vehicle. Moving on to level 4, which can be termed as a highly autonomous vehicle. So autopilot will perform the driving task under defined circumstances such as low speed traffic jams and urban driving. Furthermore, a human driver is not needed and the system will run automatically. Therefore, the vehicle will react to an event even if human driver is not available to respond when requested. And finally, the level 5, which is the fully autonomous vehicle. So here driving task is solely performed by the autopilot in all roadways and environmental conditions. Humans act only as passengers and therefore no humans are required for vehicle operation. One thing to note is as the level of autonomy increases, because the car has to make more decisions, specifically level 1 vehicle could consume up to 3 gigabytes per hour, whereas level 5 vehicle consume 50 gigabytes per hour. Indeed, level 5 vehicle will consume almost 17 times more data than the level 1 vehicles. So overall, the autonomous vehicle will transmit data totaling to 3,500 exabytes by 2050. So if you put it in a context, 3,500 exabyte is equivalent to 40 times the global current wireless data traffic. The autonomous vehicle consumes 3 data streams via their sensors and onboard computers. So the first is navigation, where data is captured by several sensors, including radar, camera, sonar, and maps. Telematics, which will use component sensors. Typically, autonomous vehicles use telematics for real-time updates of car diagnostic and to provide over-the-air software updates. And finally, infotainment, which includes video streaming, like high-definition video content on Netflix, etc. In terms of the technical standards, there are two: cellular vehicle to everything and dedicated short-range communication. In dedicated short-range communication, it will not require the traditional cellular network. Instead, vehicle will connect directly with other vehicles in a similar way to Wi-Fi and Bluetooth technology. However, cellular vehicle to everything is a dominant standard for autonomous vehicle technology. Hence, we will focus on cellular vehicle to everything in today's Tech Talk. So just a quick overview on the cellular vehicle to everything. So cellular vehicle to everything will allow autonomous vehicles to connect to the network and transmit data. This mobile standard has subgroups, as you see on the screen: vehicle to vehicle. So vehicle to vehicle technology will connect a vehicle with other nearby vehicles, allowing vehicles to communicate with each other. The purpose of this platform is to transmit real-time data around driving patterns and relative positioning between vehicles. Typical use cases of vehicle to vehicle includes collision avoidance safety systems, slow or stationary vehicles, traffic jams and road works ahead, etc. Vehicle to infrastructure connects vehicle directly with urban infrastructure, example, road, traffic signs, lights. The purpose of this platform is to transmit accurate real-time data about the current state of infrastructure. For example, this includes the width of the road and if any turns are coming up. Similarly, the underlying technology for V2I is the Internet of Things. Typical use cases would be weather condition information, intersection safety assessments, etc. Moving on, vehicle to network. So vehicle to network technology connects the vehicle with the rest of the world through the use of cellular network. Typical use cases will be infotainment, real-time traffic and routing, including 3D mappings, connection to the cloud and edge services. And finally, vehicle to pedestrian, where vehicle to pedestrian will primarily allow for safety alerts to be sent to pedestrian and cyclist from vehicle. So, with all these technologies in autonomous vehicle, what are the 5G implications? So in 2G and 3G wireless technologies, the automotive industry with its established manufacturers, supply chains, and technology system did not have much of a partnership with telecommunication. However, in 4G, the automotive supply chain and technology systems of the vehicle began to be disrupted by cellular technology with the introduction of telematics connecting the vehicle to the internet. In 5G, user experience, including the way users will drive the vehicle, service the vehicle, and interact with the vehicle, is now being framed like an experience similar to that of a smartphone. In terms of the spectrum, let's hope that there would be an allocation of a clean spectrum to cellular vehicle to everything, because this will be important to allow the technology to function safely. Moving on to Industry 4.0. So Industry 4.0 will be a game changer. However, let's look at the evolution of the industry revolution still today. So the first industrial revolution was marked by the transition from hand production methods to machines, typically steel and water. Main source was coal. Industry 2.0, which was also known as technological revolution, roughly covered the period between 1817 to 1914. It was made possible with rail network and telegraph, which allowed for movement of people and also transfer of ideas. And here, obviously, the major source of power was electricity. Industry 3.0, or third revolution, is known as the digital revolution. It started in 1969, and it was an interesting revolution because there was advancement of computers along with the introduction of programmable digital logic circuits, which created the possibility of intelligent system able to automate tasks through the new level. Robots are the prime example. And finally, Industry 4.0 is basically Industry 3.0 with the help of smart and transformative technologies. This means by combining big data analytics, etc., where tasks could be performed not just faster but better. So let's look at some basics before proceeding further. Just to know, Industry 4.0 originated in 2011, and typically this was a high-tech strategy project by the German government. When we talk about Industry 4.0, we often use terms like IoT, IIoT, and Industry 4.0. So there is always a question, what is the difference? So IoT pertains to consumers and commercial sector. Typically everything from signaling to surveillance to building temperature control systems, etc. Industrial IoT or IIoT refers to the industrial sector, and it is an enabling force for Industrial 4.0 connected devices. Data, machines, and people benefit, and as a company or a customer, the goal is to manufacture the best possible product. So now let's touch base on some use cases of Industry 4.0. So the first use case is automated guided vehicles. So at factories, automated guided vehicles now rely on sensors to assist with navigation and collision control. They typically operate in fixed path or have only basic capability for optimizing route. The next generation of AGVs will use advanced analytics and machine learning, which is the ability of the computer system to analyze information and learn. These capabilities will allow AGVs to review data and make sophisticated navigation devices. Next one is 3D bin picking. So at most factories, machine pick parts from bins by taking items from fixed location. With 5G IoT, robots will be able to use sophisticated vision systems to locate part regardless of their location. The third one is augmented reality. So workers can use augmented reality glasses that display instructions in their visual field to guide the workflow in various tasks, such as quality inspections. Here, 5G is an enabler since AR glasses must process data in real time to provide a seamless as a responsive experience. Uh, the next one is vision quality checks. Using artificial intelligence, it enables significant performance improvement in vision quality systems. Thanks to its low latency and high reliability, 5G will improve such remote and real-time analytics by allowing vision quality system to spot deviations and work quickly. Quickly on the private network opportunities. So with the advent of 5G, industrial companies are becoming more interested in private network because they satisfy their stringent data security requirements while simultaneously providing great reliability, performance, and coverage. Real-time processing control, again, the companies can capture significant value by using advanced analytics application to optimize and adjust process parameters in real time. So this was all about Industry 4.0. Moving on to 5G on healthcare. So there are some use cases in healthcare. So telemedicine. So effective telemedicine requires a network that can support near real-time, high-quality video without slowing down the facility's network. Adding a high-speed 5G network to existing architecture can support near real-time video for video-based medical consultation to improve access to care and quality of care. Second use case is remote patient monitoring. So hand in hand with telemedicine is remote patient monitoring. This includes administering and adjusting medications based on collecting and analyzing near real-time data. By using IoT devices, healthcare providers can remotely monitor vital, track medications, and transfer current data to help staff make faster and informed decisions. Third is augmented and virtual reality. So typically by using augmented reality and virtual reality to care for patients and to train clinicians. Data analysis, this is again for proactive analysis and this will also help enable innovations in terms of early remote diagnostic, remote surgery, smart hospitalizations, etc. And finally, decentralizing the healthcare models, 5G will further accelerate the industry trend toward providing closer care to the patients outside the hospital setting. Moving on to the large file transfers, 5G will be able to improve hospitals' ability to transfer large image files. When a network is low on bandwidth, this hampers. So, in terms of 5G, it will have a capacity to enable faster transfers of huge medical images with exceptional network performance. Now we have seen through all these use cases, finally looking at the bad effects of healthcare, uh, uh, I would say on human health, 5G on human health. So the 5G mobile network has been switched on in some UK cities, and that has led to questions whether the new technology will possess health risk. So what are the concerns? And typically, as with the previous cellular technologies, 5G network relies on signal carried by radio waves, which are part of the electromagnetic spectrum. We are all surrounded by electromagnetic radiations at all time. 5G uses higher frequency waves than the earlier mobile network, allowing more devices to have access to the internet at the same time at the faster speed. This wave travels shorter distances through urban spaces, so 5G networks require more transmitters than previous technologies. So the concern is the electromagnetic radiation used by all mobile technologies have led some people to worry about increased health risks, including developing certain type of cancers. However, as per WHO, there is evidence that falls short of being conclusive that exposures may cause adverse effect to humans. So, with this, I end my tech talk on 5G and impact on industries. I hope it was informative. In case of any queries, let's meet in the live question and answer session. Thank you.